Here's a couple of the problems on the Chapter 6 test review sheet I wanted to work out for you. This is number 20, which is a probability problem. And what we're told is this person has a 60% probability or likelihood of making a free throw. So let's write down the given percentage. That's just another way of saying 60% in decimal form. And I always like to, when I'm working these out, I will write down the percentage that's given, okay, and label it. What does this refer to in the problem? Well, this is the likelihood he's going to make. Well, right beside that, I need to write the likelihood of the alternative, which of course is missing. So if he's 60% at making them, then he's got a 40% chance or probability of missing. Just remember, in decimal form, these two decimals should add up to be 1, or in percent form, they would be 100%. Okay, so that's where we start, and now we look at what the problem is asking for. What is the likelihood that he will make 4 out of 7? So let's take the make probability and we'll raise it to the 4th power. And if he's going to shoot 7 free throws and make 4 of them, that means he's going to have to miss 3 of them. So we'll raise the miss probability to the 3rd power. Okay. Now remember, we're using the binomial theorem really to answer this question, but we're only choosing one of the terms. If we expanded this whole binomial out, it would be 8 different terms in the expansion. But we're only selecting the one that's needed to answer this particular problem. Okay? But remember, when you expand using the binomial theorem, you're going to have a combination factor. Okay? So here's how we'll get that. Since 7 free throws are being taken all together, that means the number n in front of C is 7. And you can always remember this second number that follows C like this. It should always match the, if you set it up this way, it will always match this second exponent, or the exponent for the failure percentage or probability. All right, so all of this now can be done in your calculator, so I'll try to step you through that. So got your calculator handy, you'll do 7 and then find the NCR option, and then 3 times, and then we're going to do 0.6 raised to the 4th power times, and then we're going to do 0.4 raised to the 3rd power. Hit the equal key, and the decimal is what is shown on the calculator, but we want to put this in percent form, and typically you can just round these to the nearest percent. So when you change the decimal to percent, remember you just slide the decimal point 2 places to the right, so that makes 29.0304, but to the nearest percent we would just say 29%. So that would be your answer for number 20. Okay, let's take a look at number 21. And this is a quadratic function because the highest exponent in the function is 2. So remember what these look like when they're graphed. You don't have to graph this, but I just want to maybe give you a way to remember how to find the answers to these questions of what is the highest or what is the lowest value on the quadratic. Well, quadratics they create parabolas. Okay, so I'm just going to draw a rough sketch of a parabola that opens up like this one would. And if we want to find the lowest part, the lowest value, or we use the word minimum when we talk about parabolas, then we're basically talking about the vertex, the very bottom point of this upward facing parabola. So really, when you're asked questions like this, given a quadratic function, and you're asked to find either the lowest or the highest in the case of a parabola that opens upside down, it's really just saying find the vertex. Okay, it's using a lot of fancy language, but in essence, what they want you to do is find the vertex of this function. Well, for standard form quadratic functions like this, we let me go ahead and label A, B, and C. That's what standard form looks like. Well, the first thing you will want to do when you find the vertex is you want to find the AOS, and remember this formula. You're going to do the opposite of B over 2 times A. Okay, well, I've already labeled those letters. B in this case is negative 90, and A is 0.3, but we're doing 2 times 0.3. Now remember, the formula says let's do the opposite of whatever this is. Okay, so let's grab your calculator, and if you want to, you can do the parentheses first. That's negative 90 divided by, you can go ahead and do 0.6 or 2 times 0.3 if you want the calculator to do it, but make sure you use parentheses around 2 times 0.3. All right, and in the parentheses, we would get negative 150, okay? Well, the sign out here, the opposite of that, makes it positive 150. So basically, for purposes of this function, you just found out what n is. N stands for the number of cars. That's not what you're asked to ultimately to answer, but we need this number to come up with the answer, what is the lowest per car cost. Okay, so now that we know what n is, we're basically going to evaluate this function like this. Remember how to find the value of an input? Basically, we're saying if 150 is the input of this function, what is the output? And the output will give us the answer to the question, what is the cost? Okay, so let's just see. We're going to put this in our calculator, and I'll show it just like your calculator would show it. 0.3 times 150 raised to the second power minus 90 times 150 plus 12,450. Okay, grab your calculator and put that in. 0.3 times 150 raised to the second power minus 90 times 150 plus 12,450, and we get 5,700. All right, and it's a cost, which means dollars, so we should put $5,700 would be the lowest cost per car. Okay, well, I hope that looks familiar, because we just did the same thing that we did back in chapter 5 when we graphed quadratic functions. This is how we found the vertex. Okay, so if you can remember how to find the vertex using opposite of b over 2a, and then turn right around and plug that number back into your function to get the final answer for this question. Okay, well, I hope that helps, and if you need further help, come and see me during academic support.